So today I would like to talk about Terraform and some cases when Terraform was not enough and we helped to bridge the gap between our implementation by using Python and Typer. So as it was mentioned that I am Yuliia Barabash, I work on daily basis with Python, AWS, and Terraform, so pretty much I'm aware of this topic. And today I would like to share some of my experience that we came through in our project. As we know, as I'm already in the IT for 5 years, and during these 5 years I was in small projects, I was in big projects, and usually in big projects where you learn the most, because in big projects you have big code base, and you need to learn how to handle everything and manage everything. For example, if you have a lot of repositories, you need to have a way how to maintain everything. You don't want to use a lot of technology, so you try to use what you have. If you cannot manage everything, it means that GitHub ghosts will come after you, will hunt you until you do not fix everything. So we have to learn how to manage everything. That's why people came up with automation, because automation is like a nice tool, according to the books, which helps to speed up your delivery and decrease your maintenance, according to the books. But sometimes in real life, we also maintain pipelines, because they always failing, we always have problems with them. That's why also people come out with continuous integration, continuous delivery, because we want to be sure that our code is tested, styled, and we always have good delivery. And we always deploy to our prod environment, int environment, stage environment, and good time to ensure that our environment is provided. One of the tools that use for deployment is basically Terraform. It's open source tool. I think here a lot of people knows a lot about Terraform. And basically, it's tools that we use to manage infrastructure. We also use Terraform, as I mentioned, is to provision our infrastructure, is to manage our infrastructure. Has a lot of benefits, because we can have a lot of different environments with the same setup. And one of the examples of just simple code, I prepare that how we can create simple resource. For example, in case we want to create S3 bucket, what we need to specify, we just need to specify the resource. We need to specify name of the bucket. We need to specify some properties, name of the bucket, so type of the resource, S3 bucket. After it, we specify some properties of it, for example, that it's the name of the bucket and the versioning. And it's enough to create a resource. But in Terraform, it's also possible to provide some behavior attached to our resources as behavior. For example, you can specify a lifecycle, you can specify provisioner and triggers. Lifecycle of provisioner, usually we can specify with any resource. Triggers, we can just specify with null resources. And for us, it was quite useful. For example, in case of here, we specify for a source S3 bucket that we prevent our destroy. So in case of deployment fail, something will get wrong, we will not destroy our S3 bucket, and we will ensure that it will stay in production. And how Terraform basically knows what to do. As I mentioned, Terraform is like use declarative language. So with declarative language, we specified what kind of resources we want to use. But providers is basically who will do the main job. It means that it's kind of the plugins that will parse our code. It's written in Go. It will translate to specific API calls and will execute against some specific API. In our case, for example, an AWS. Most of the time, there's a lot of providers. Right now, there's more than 4,000 different providers. So it has to cover. Also, it's open source. A lot of people contribute every day, changing something. But here, we have our use case. In our use case, we thought it would be nice to extend our implementation. It would be nice that it would be possible to serve something like data to the users. For example, people can go to our websites and they can use search engine. It means that we need to extend our implementation. We need to host OpenSearch index. For OpenSearch index, we would like to use Terraform, and we started to think what we can use it. So we can use Terraform for managing instances. We can use for security access. And we thought, OK, we can also use for indexes in index templates. Everything was smooth. We deployed, we ran it, we tested. It was good. So we were extremely happy. Time passed. Came new feature. We want to extend the new feature. It means for extension of new features, we had to update our index. We need to update our index in place, in production, also in int. And is any database, if you want to change like properties of your database, for example, properties of some field, you had string, you want to have Boolean, you cannot just do it. You need to destroy it, you need to recreate it, you need to import your data, and after that it will be good. In this case, it's OpenSearch, it was the same. It means we need to destroy our index, we need to recreate it, we need to import all data. What it means for us? It means downtime. It's a very not happy moment when you have downtime. You need to tell your users it will be not accessible, and we always try to avoid this. That's why we came with idea that there should be some simplest process. The process is clear, that we know that we need to create an index. We need to reindex our data from old index to the new one. We need to reindex our data from new index from the old index to the new index. After that, mark our index as ready to use and destroy the old index. It's quite easy. Process is simple. However, Terraform doesn't support this. That's why we thought to divide a bit responsibility between Terraform and Python, because in Terraform you can still check and use your index templates. So Terraform can still take responsibility of the serving index templates. Meanwhile, the Python can basically take responsibility of the index, because so it can track all indexes, create all indexes, and reindex your data from the old one. But for this, we need to have nice wrapper that it's possible to run from Terraform, and to be sure that it's easy to use, it's easy to maintain. That's why we thought about Typer, because Typer can be a nice tool that used for CLI that can be, we can create and maintain, and basically entry point to our code. And it has pretty much simple functionality. For example, in case you want to create application, it's very very simple. For example, for creation of application, you just need to define type of the typer instance, and after that use it as declarative together with command and register specific function, for example, reindex, and after that you can just call from your command line. For example, here we have Python main.py, and after that we put the name of our command, and after that we specify some parameters, users. Here I use Python main.py because I run from the script. We need to specify script where is our CLI tool is located. But in case of the production time, or you want to use locally, you can just add to the path, and you can use it from there. With this, it's also very simple to use index. It's very easy to pass arguments, and also very easy to pass options. For example, to define arguments, you just need to specify index, and type of it will be typer argument, and typer will understand it, parse it, and it will be very easy to use. In case of arguments, there's two types of variables that you can pass inside. So there's arguments and there's options. With arguments, they're always required. If you specify on the first place, it always has to be in the first place. If you specify on the second place, it always has to be on second place. And it's a requirement field. Also, there's possible to have some like helpers that people will understand, types you can use for validation. Another one is options, where you can just pass like a tag. It's not required. It's optional. And for it, you don't need to keep the location before using. You just specify the target, and it will be very easy to use. Your flag, for example. We have here, again, we want to call our command. We just call it like reindex. After that, we specify our parameter, the first argument, as users. We don't use here any flag because it's requirement field. After that, we use flag target and specify that our second parameter, it's optional, user2, in case you want to reindex your data in another place. It's the easiest and what you need to set up your tools, simple CLI command. In case you want to have something more complicated, and what I like typer, it can pass your environment variables. It can be useful in case you also want to use in GitHub pipelines where you don't want to reveal your secrets, but you want to retrieve it from environment variables. You don't need to pass, for example, user as password anymore to your variables. You just need to specify in the options that nvar, username, nvar password, and it will retrieve from your environment variables. Another thing that you can notice here, that we also specify here callback. It's quite important because callback is basically will be like entrance point to your CLI tool. For example, before execution of another subcommand, we always will execute callback. It means that it will be the first pointer in your execution of the code, of the application. For example, in case you want to connect to database and you want to always be ensured that you have connection to your database. You don't want always to later discover that your database is not working. That's why callback is important, because it will be just act as a first entry to your code, and you can just execute it. So we will execute during our execution of the script. What of other things? It's very important that we also can use context. For example, with the context, we can persist the state between different commands. For example, in case you want to have connection, you again want to establish a connection, you can just store it in the context. After callback, you will execute another command, for example, reindex. You will just retrieve from the context, and it's ready to use. So, and you do not pass your credentials everywhere. You just, as entry point, you retrieve this from your context that will be shared across different commands and subcommands. Another thing that it's important, how basically we found a way how to combine it. So as I mentioned, typer, we have already nice command line interface that we can use it and we run it. And we have Terraform that we want to run during our deployment. And what of the strategy was to use is basically, as I mentioned, is to try to use provisioner. Because provisioner is where it has local execute, where you can execute scripts locally before, after successful creation of your resources. And what of the examples of it? For example, null resource. because with null resource, you don't create any resources, but you can specify provisioner that we will execute. For example, we specify just simple command. We specify that we want to use our command line interface and execute it. After that, we call our command reindex, reindex and specify index. Additionally, we can specify our environment variable like username and password. And after it was successful, it was executed. Additionally, as we want to be sure that we trigger our script on changes, we also, it's possible to specify triggers. Usually triggers will trigger creation of resource, depends how it's changing. For example, with index settings, we specify that always trigger when index settings is changing. It means during this time, we'll execute this resource. It will create a new index, it will reindex everything, and it will be ready to use. And it's help us to avoid downtime, to handle all our implementation. Additionally, it's quite nice to use because in case you have AWS artifacts, you have private private registry for your libraries, you can just run pip install your CLI tool, and it will be easy to use. The same for GitHub pipelines, it was also quite easy to use. And conclusion that it really avoid us downtime, to lose our data. Also, we can execute some additional functionality for Terraform. It will help us avoid some problems because it was not nice when you lose your data during deployment. And it was nice, a lot of features, for example, getting environments variables, good printing. We can log all our information that we need, easy to declare commands, easy to declare arguments, and it's quite easy to use. And that's all, and thank you for your attention.
Thank you, Yuliia, for your talk. We do have one question in Slido, so you feel free to add more. One person asked, is there an architectural difference between time series and non-serialized data in regards to the position of a row or column?
What do you mean?
I don't know.
Who asked this?
I think this is not related to this presentation.
Wait, sorry.
Somebody placed it in the wrong room, probably.
Probably, thank you. True, so this one is related because it mentions Terraform. I didn't get the problem of reindexing in Terraform. Can you repeat it once? Thank you.
The thing is that with reindexes, in case you have a big instance, you store your data in indexes. And usually with OpenSearch, you have two types how to map your data inside index. Because, for example, it has like, it can decide on its own how to index data. Sometimes you want to decide index template. It usually index template. It will try to match types of your fields with the data that you inserted. So it's like schema for your indexes. And in case with OpenSearch and also with Terraform, how it works, it does not update your index in place. Instead, it will just, in case you will just change some properties of your index, even you don't just change like mapping of your fields, it will destroy it and it will recreate it and you lose your data. And it was not, it's quite fragile solution for us because in case you just change it, you deploy it, it will destroy a lot of stuff. That's why we decided to have this separation. So we just, with Terraform, we create index templates where you put information how to map our fields, how to properties of the indexes. And with Terraform, we create index. And it means when we create index, OpenSearch tries to find appropriate index template and map data correctly. Yeah.
Thank you. One more. Was this approach tested on Terraform Cloud or only local execution of Terraform?
It was tested on AWS Cloud.
On AWS Cloud, okay. There's one more. Let me check. Do you have any experience in integrating Ansible with Terraform? There are a lot of Ansible modules for stuff like reindexing databases.
No, unfortunately, no.
Any more questions from the audience? If not, then thank you, Yuliia. And maybe one more round of applause.